Hello. Well, you'll remember that Dick gave me this anemometer type thing, and I'm supposed to be testing that out. We could put it on the top of the mast so that the autopilot knows the direction from which the wind is coming. And I will test that out eventually when I get around to it. But of course the problem with it is that it's not marinized, it's not properly waterproof, so if it ever did get dunked in the sea, I feel sure it would stop working. So we'd have to actually use it for test purposes and then make a better one for the real mission. But I've always had it in mind that we might be able to deduce the wind direction from the data that the autopilot logs on its SD card, and this video is just a short sort of desk session to demonstrate how that could be done. You remember we did a session on Bray Lake on May the 10th, and this is the leg from Alpha to Bravo, and the boat is just turning through the wind, and you can see the jib moving across. So if we stop that film just as that starts to happen, we find that it's actually happened at 10:40:41, and the heading was about 300 degrees. So we deduced that the wind at that time on the lake was 300 degrees. Later, when we were going from Charlie to Delta, we thought that the wind was more of a westerly direction because the boat was goose-winging. It's hit Charlie, we're going for Delta.
Right.
So it applies.
Delta, here we come. Now it's trying to goose wing.
Well, that's fine. So the autopilot writes this log file into an SD card for the whole of the trip. And one of the things it records is that the helmsman reads the compass about once a second. And it records not only the heading of the boat, but also its roll and pitch. So I thought that if we were to make a histogram of the average roll angle against the heading of the boat, we might be able to deduce something about the wind direction from that. So I wrote a program to do that. And what I've basically done is divided. What we've got here is a 360-degree polar diagram: north, east, south, west. And I've divided that 360 degrees into 36 10-degree bins. And for each of those bins, I've calculated the average roll angle that we observed. And that is plotted on the red line here. So for example, if we look at this point here, now let's look at this one. Look at this point here. For angles between 70 and 80, the average roll angle was shown by the radius of this line on this scale here, which goes from minus 30 degrees, that's 30 degrees roll to port, to plus 30 degrees, which is 30 degrees roll to starboard. So following this line round, basically the average roll angle for this 75 degree bin was 10 degrees to starboard. Because this roll scale goes from minus 30 to plus 30, the 0 point is in the middle and is shown by this black line. So that corresponds to the boat not rolling at all. So if we follow this red line round and look for the point where the red line crosses the 0 roll line, this 0 roll black circle, it happens about there, which I would judge to be about 304 degrees, somewhere between 300 and 315 anyway. So what we're saying is if the boat is pointing slightly to the left of that angle, then it's rolling to port, whereas if it's pointing slightly to the right of that angle, it's rolling to starboard. So we can deduce that this angle here is the direction from which the wind is blowing. In other words, the wind is blowing from 304 degrees. That seems to be quite an accurate identification of the wind direction that we found on the lake. Perhaps even more accurate than our estimate by watching the boat turning through the wind. If we follow the line round further and look for the next time it passes across the zero line, that happens here. But this time, if it's pointing slightly to the left, the roll is to starboard, and if it's pointing slightly to the right, the roll is to port, because the boat is facing downwind at this point. So we could say that when the boat was going downwind, the wind was more blowing towards east, in other words, more likely coming from the west. And that's what we found on the second part of that trip when we were going from Charlie to Delta. So this technique seems to have identified the direction of the wind quite accurately. The green line simply tells me the number of observations in each of the 10-degree bins. So, for example, here in this bin we've got about 12 times 10, because this is, I've divided the answer by 120 observations in that bin. So there are quite a lot of observations because it's taking one reading every second, and in fact there were 3,016 observations in all. So we get quite a statistically significant average values in those in that histogram. So I'm quite pleased with that. I also tried another way of analysing the same data. Well, not the same data, but we also have the Autopilot, which is reading the GPS unit once every 10 seconds. So we get 10 times fewer readings, but a different kind of information. The GPS unit gives us speed over ground. So what I've plotted here is a histogram in the red line of speed over ground against the compass bearing of the boat at the time I read the GPS unit. And we expect that if the boat is pointing directly into the wind, the speed over ground will be the minimal. So if we just follow this round and look for the minimum, it happens to be there, which is, by an amazing chance, at 300 degrees. So that technique also works, but it's somewhat slower because we're only taking a GPS reading once every 10 seconds. And as you can see from the green line, we have far fewer readings. I've got only in total 162 readings. So I think I prefer this method. And I think I'll analyze a few more logs to see how satisfactory it is in different circumstances. So, calculating a histogram of roll against boat heading seems to be a possible good way of working out what direction the wind is in. Of course, we're doing this on a lake. If we were doing it in the sea, there would be waves and the boat would be rolling about in all directions because of those waves. Now, that wouldn't matter if the wave motion was entirely random, because it would just average out. But what if the waves are wind driven? Then maybe the technique won't work. I don't know, we'll have to try it. The GPS speed over ground technique is perhaps more immune to wave motion, but I still prefer the first one, the roll one. Of course, in the sea, we could just deliberately sail in a circle and collect the necessary information to build that histogram and thereby work out the direction of the wind. On a lake, we don't necessarily have the room to do that, or we don't have time to do it before we actually need to sail. If we were trying to sail away from our base point and the wind was blowing onshore, we'd need to know the direction of the wind straight away, otherwise we'd need to start tacking, or we'd just get blown onto the shore. So the technique maybe isn't suitable for all circumstances, but on a lake. But perhaps it would be okay on the sea once we've got out a bit to sea and we've got plenty of room to manoeuvre. Anyway, that's my idea for today, and thanks very much for watching.